Hi everyone. So we're going to go ahead and first discuss what is a linear equation, y equals mx plus b, and how do we graph this? And lastly, we're going to do some examples. So let's go ahead and get started. Just scroll down for the chapter you want and watch only what you need. Okay, so we're going to be getting into linear equations. What is a linear equation? Well, it's y equals mx plus b. And the different parts of y equals mx plus b is going to be, if you get, I'm gonna write it down right here. Y is considered the output. M is considered the slope. Okay. In other words, we can also say rate of change. The x is the input. Okay. And the b is considered the y intercept. Okay. So to tie this all together, I'm just going to use an illustration to kind of make little sense of this. Now, this is not the only way the slope intercept or in a linear equation is used, but we can use it like this. So imagine you got a job. Your job is paying you $7 an hour. And when you first got hired, you got paid on the spot, day one, $3. Okay, so again, my rate of change, right, is my $7. Okay, $7 per hour. Okay, my bonus, or when I first started the job, was my B. Okay, I got paid $3 right on the spot. Now X and Y, they stay the same, and X is my input, because when you get a job, your the hours that you put in, right, your input always changes per week. And then as a result, your Y, your paycheck, that always changes. You see that? So you're going to notice that in linear equations, the X and Y, they stay as letters, because in a job, the amount of hours you put in and your paycheck changes all the time. But what don't change is your actual pay. That don't change every week. And of course, once you get your bonus of $3, that doesn't change either, because then it becomes part of the past. So that's just kind of one way to understand, you know, linear equations. Um, but now let's go ahead and actually start to graph a linear equation. So how do we actually graph a linear equation? Well, I got a little graph here, and on this graph, we're going to graph that same equation of y equals 7x plus 3. So y equals 7x, write that y a little better there, plus 3. Okay, so in this equation, again, remember that 7 is the m, or the rate of change, and in this illustration, it's going to be $7 an hour. And of course, x is hours. Okay, so x is hours, and y being the result, your paycheck, the amount of money. Okay, so how do we first plot it? Well, our b is going to be our 3. Okay, that is the y-intercept. Now if you look at this, this is the y-axis, and 3 is right here. So the y-intercept for this line is 3. Okay, that's the y-intercept. So you work no hours, and your bonus happens to be your $3. You just walked in the door, you already got $3 that you're going to collect for starting this job. Now, what if you actually put in 1 hour? Okay, well, I can actually calculate this on the left hand side. It's y equals, I put 7 times 1 hour plus 3. Okay, y equals 7 times 1 is plus 3. Y equals 10. Okay, so on my first hour, hour 1, I have $10 already I'm going to collect. Now, again, remember that our bonus right there, I have worked no hours and I already collected 3. But that's how you really graph a linear equation. If you only need 2 points to graph a linear equation, right? And once you get your 2 points, you can just draw a line through them right there. And when you draw a line, um, you can be comfortable that this line is not going to change direction. Okay, that's why you only need 2 points. It's not like this line is gonna go in this direction later on down the line or not. But and that's really how you graph a line, linear equation. Okay, now so let's actually do some examples. We have our problem here: y equals 3x plus 4, and pretty straightforward. What is our y-intercept? Our y-intercept is 4. Remember that y-intercept crosses the y-axis, right? So 1, 2, 3, 4. Now keep in mind that on the y-intercept, x is always 0. Okay, so that's the coordinates for that. Now I haven't actually talked about this just yet, but instead of actually calculating what would 1 be, if x was 1, just keep in mind that the 3 there, right there, that means m, that's the m, right? M equals 3. And slope can be considered as rise over run, okay? So remember, we're going back to that job again. That's like $3 per hour, okay? So I can literally just look at my first point here, at 0 hours, I got my bonus of $4, and this is my rise over run, right? I can literally just count up 3, 1, 2, $3 for 1 hour. And just to be kind of technical here, we can kind of really repeat this if you wanted to. 1, 2, $3 for another hour. Okay, and that's really the slope there, that rate of change. Again, you only need 2 points to draw a line, because once you get those 2 points, you got the direction and the position of the line. That's not going to change. And make sure you draw a little arrow on each end to say that this line is continuous, and that is how you graph that line. Let's take a look at another example over here. Now, this one is actually a negative slope, and there is no job out there. There's no job out there that you work and pay them. That doesn't work. So we're gonna have to use a different picture to explain this one. So let's just imagine that instead of x being hours, let x be days. Right? Let's x be days, and y. You can just say, to keep it simple, we'll just use dollars. Okay. All right. So say that you decided to open up a lemonade stand, and on day 0, you had already saved up $4. So on day 0, 1, 2, 3, right? On day 0, you have $4 in your bank account. Now, the minute that you start your first day, by the time you end your first day, right? This negative slope is telling me that you're losing money. Okay, so let's look at that slope right there. That's m equals -2, and -2/3. So that is, I'm losing $2 on a rate of 3 days. Okay, so I go down 2. I go down to $2 over 1, 2, 3 days. Okay, and I only need 2 points, but on day 3, I have now $2 in my bank account. Again, if I continue going and try to keep this lemonade stand going, I'm gonna be broke. 1, 2, 3. By day 6. So 4, 5, 6. Okay. So as you can see, a linear equation doesn't always just mean the job. It can model really a lot of things. It has a lot of practical applications. Um, so in this case, apparently this person who opened up their lemonade stand, they are not making any money. They're losing money. And as a reminder, you only need 2 points really just to draw that line. All right, so let's go ahead and actually get our last example here. Now this is another business. Let's just say that this person, they didn't save up any money. They didn't save up any money, and they borrowed money. Right, they're in the hole of $2 from the day 0. So let's go ahead and label X again. Let's go ahead and label X as days. All right, and Y is going to be our dollars. Okay. All right. So um, on day 0, the y-intercept, we already at a hole of -2. Okay, on day 0, -2. But this person's business happens to be working for them. So again, if you look at that 1/3 there, right? If you look at that 1/3, that really means I gain $1 every 3 days. Okay, so uh, slope is measured in rise over run. So I go up 1. I go up 1 over 3. 1, 2, 3. Okay, and I plot my next point. So I'm slowly but surely climbing out of this hole. So on day 3, I at -1 of my bank account. But then I keep working, and I'm slowly starting to feel like I'm actually breaking even here. So I get up another dollar. 1, 2, 3, and I am now out of debt on day 6. Okay, so day 6, I have $0 in my bank account. Now again, to really just to get this point across, I do not need to draw more than 2 points here. Okay, so if I just have these 2 points, I only can really just I can the line is going to cross all the other points I'm going to draw in the future. So you only need just 2 points to draw a line. But what's important is that the concept. You get that concept when you start running into those word problems, then it's not so foreign to you. This is not just a bunch of numbers, letters, and labels on a grid. So hope this helps. Hope you enjoyed this video, and see you next time.